I hope you all are doing well. Good morning, good afternoon, good evening, or good night. You can take whatever greeting suits you the best. Today we are going to learn about ambiguity in CFG and CFL. Ambiguity simply means the confusion. Confusion for whom? Confusion for the machine to decide. Um, confusion, confusion for machine um, to decide to which state to go after processing a string or a character. In simple words, ambiguity here can be also depicts like this. If there is an equation, mathematical equation like this, 3 plus 2 into 2, then there will be two outputs of it if we haven't given the brackets to it. Which can be like this. If we do addition first, 3 plus 2, 5, 5 into 2, 10. Then here will be one output called 10. And if we do multiplication first, then there will be 2 into 2, 4, 4 plus 3, 7. 7. Like this, like this confusion can also be occurred to the machine if the grammar is not uh, structured in proper way. Suppose we have given here brackets. So अगर हमने यहाँ ब्रैकेट्स दिए होते तो हमारे हमारे लिए बहुत इजी हो जाता आउटपुट निकालना। वैसे ही मशीन के बारे में कि कंटेक्स्ट फ्री ग्रामर अगर एम्बिजियस हो तो मशीन को बहुत डिफिकल्टीज फेस होती है कि प्रोसेस करने के बाद की स्टेट को जाए और इफ देर आर मोर देन more than one output, which output should be displayed. So, we will dive deeper into this topic further. Hmm. Simple introduction. CFGs define syntax for programming or formal languages. CFGs are nothing but the context free grammars, which define syntax for programming or formal languages. We all know. Ambiguity occurs when one string has multiple parse trees, whether it is leftmost tree or rightmost tree. If there are multiple derivations for single string, then from a CFG, of course, then there will be definitely ambiguity occurs. We will see this with an example here. Okay. Suppose we have to derive A, B, A, B. You have to adjust with my handwriting because I don't have mouse with me. My mouse is broken by my cat. That was a joke, but really my mouse is broken. Okay. Now, how we will derive this string using this grammar here. Okay. We will first derive this grammar ABAB with leftmost derivation. I will further explain you why this derivation is called leftmost and a derivation called rightmost. This is all nothing but the terms, but very simple terms actually. These only terms are difficult when we hear it, unless and until we try it by ourselves. So, okay, enough of this nonsense. We will straight to the derivation here. So here first we take this ASB from this grammar. Why ASB? Because ASB has starting symbol as A and ending symbol as B, which is perfectly suitable to derive our ABAB string. Okay, so from here, now from this ASB, we again have to replace this S with one of the production rule here. So we will replace this S with BSA. You will get to understand why we are doing replacement here when we get our result. Okay, so you can see that here we have epsilon in production rule. What this epsilon means? This epsilon means null. So we will replace this s with this null. Then when we replace this s with null, we will get our exact required output, which is ABAB. This is nothing but the leftmost derivation. Now we will see rightmost derivation. See, I am having so much difficulties because I'm using the keypad. I don't have mouse. I've told you earlier, you have to adjust my handwriting. Now, in rightmost derivation, we will start our derivation from SS. Okay. So now, as this derivation is, पप्पा इथं येऊन कशाला ठेकर मारला हो काय सगळे गोंधळ घालतेत बाई सगळे थोडं पुढं केलं तरी काय व्हिडिओ करायची केव्हापासून जाऊ दे पुढं So in this rightmost derivation, we will first derive this s present here at right side of this reduction rule. So we will replace that s with ASB. You will exactly understand why these derivations are called leftmost and rightmost in further this video. Now this s, not the leftmost, but the rightmost s will again be replaced by, can you guess? Hmm. PSA. Okay. Now, can you guess what will be our next step? Yes, absolutely right. The now both the s will be replaced with the epsilon here. Then epsilon is nothing but the null, so we don't have to write here anything. We can simply write it as ABAB, which is our required output. Yes. We will head to the next slide. Yes. Leftmost derivation. Leftmost derivation, what it does. We have seen earlier. This is the same example. Okay. Leftmost derivation replaces leftmost non-terminal first. Okay. Now what is mean by non-terminal symbols? Non-terminal symbols are nothing but the all the small alphabetical letters here. Sorry, by mistake. Non-terminal symbols are the all capital case letters. Okay, and terminal symbols are all small letters here. Okay. Derivation tree shows how the string is derived. Yes. Now I will show you the derivation tree. How to draw derivation tree. Now here our starting symbol is S. Now there will be three branches A, S, and B. Now again this S is we are replacing with BSA. That's why again three branches. Okay. And now this S is replaced by null. That is our epsilon. This is our leftmost tree. Now we will head towards the rightmost tree. Okay. Rightmost derivation replaces rightmost non-terminal first. How will be the derivation tree of this? S. Then there will be two branches as there are only two production rules. Now this rightmost S will be again replaced by ASB. So there will be three branches. Okay. Now here this S is okay. In this example, they have derived the rightmost derivation with another trick. So we can see that for this example, we will having two rightmost derivations. First one I explained you uh, previously in the second slide, and now here in this slide, the derivation is different. Okay, no problem. You can use this also to prove that the grammar has ambiguity. So here this S is replaced by ASB again. Okay. And these s will have epsilon. This is our ultimate. Okay, we can write it here. This is our ultimate rightmost derivation. We will head towards the next topic. I mean, next subtopic of this video. Observations on derivation. We have seen in this example that we derived two rightmost derivations. One I explained to you in the starting of the video, and one in previous slide. We have one leftmost derivation. So what we can say that in this and a grammar can have more than one, either leftmost or rightmost or both the derivations. Okay. CFG is ambiguous if a string has more than one LMD RMD derivation tree. Example, multiple derivations from for ABAB, as we seen earlier. Now ambiguity in CFL. CFL is inherently ambiguous if all CFGs generating it are ambiguous. Okay. Context-free language is inherently ambiguous if all context-free grammars generating it are ambiguous. Inherently ambiguous languages cannot be represented by unambiguous context-free grammars. Here is this example. Key points what can we take from it is am, ambiguous context-free grammar gives language which is may or may not be ambiguous. No algorithm to convert ambiguous context-free grammar to unambiguous. There is no algorithm. Deterministic context-free languages are always unambiguous. Okay, these are the key points you have to remember. Why ambiguity is a problem? I told you in the first slide, in the overview of this video, that parsing becomes difficult with multiple interpretations. Compilers need unique syntax interpretation. Ambiguity increases complexity in implementation, right? Sample problem 1. So, mm, you can verify the answer of this question by yourself. Okay, the answer of this question will be B, 1 and 3 only. Okay. Also, these two examples are for your homework. And thank you for your valuable time giving us and watching our YouTube video.